Welcome back to Summarize Science. Have you ever wondered how drones can perform complex jobs like inspecting power lines without crashing? It's a huge challenge, especially in cluttered environments like a power substation, which is full of equipment. Today, we're looking at a paper that proposes a clever two-step solution for planning the perfect drone flight path. The researchers frame this as a classic problem with a modern twist, the traveling salesman problem. The drone is the salesman, and it needs to visit a set of points of interest for inspection. But it's not just about finding the shortest path. The drone also has to fly smoothly and, most importantly, avoid all the obstacles in its way. Their solution starts with what's called a genetic algorithm. Think of it like digital evolution for flight paths, where only the fittest survive. The algorithm creates a population of random paths, then breeds the best ones, combining parts of the most efficient routes to create even better offspring. This process quickly finds a near-perfect order in which the drone should visit all the points, as shown by this initial red dashed line. But as you can see, that first plan is just a series of straight lines that cuts right through the red obstacles. That's where the second stage comes in, an optimized B-spline. This is a sophisticated mathematical technique that takes this sequence of points and turns it into a smooth, flowing curve. The algorithm carefully bends and shapes this path to steer clear of all obstacles while also optimizing for time and energy. The final result is this much safer and more realistic green trajectory. And the results from the simulation are impressive. This 3D view shows the final planned path and how the drone gracefully weaves around the cylindrical obstacles while covering all the necessary points. The researchers also analyzed the drone's flight data, which confirms the flight was incredibly stable and smooth. These graphs show that there were no jerky motions or sudden changes in direction. The roll and pitch angles remained small, and the velocity changed gradually. This is exactly what you want for a safe and effective inspection mission. So, to recap, this research combines two powerful techniques to solve a complex problem. First, a genetic algorithm finds the best order to visit the inspection points. Second, an optimized B-spline creates a smooth, safe, and efficient trajectory based on that order. This kind of smart planning is crucial for making autonomous drone inspections a widespread reality. It could lead to safer, faster, and cheaper maintenance of our critical infrastructure, like the power grid we all rely on. Thanks for watching Summarize Science.